We're moving on to 4.5, and 4.5 is pretty large, so we're going to spend 2 class periods on it. So we are going to review trigonometry, so hopefully you remember some of this from previous classes. So on your calculator, which I didn't have ready to go, I'm sorry. Your calculator has 3 trig buttons on it. Oh boy. So your trig buttons are sine, cosine, and tangent. Don't call them sin, cos, and tan. People will make fun of you. Sine, cosine, and tangent. And those are just the names of ratios. So if I draw a right triangle, the longest side is always called the hypotenuse. And hypotenuse is a Greek word, and if you translate it into English, it's a little bit strange, but the rough translation is an occupied toilet on the top of a mountain. Wait for it. Wait for it. No? An occupied toilet on top of a mountain. Nobody. High pot in use. Oh, there we go. That was a terrible joke. So the hypotenuse is the longest side. The other 2 sides we call legs. Okay? And the legs are shorter than the hypotenuse. And when we do trigonometry, we have to choose one of the angles. So if I picked this angle, and a lot of times when we pick an angle, we use a Greek letter, theta, just like pi, alpha, beta, gamma, delta, zeta, eta, theta. It's just a Greek letter. So if I choose that to be my angle theta, then I have 2 legs. One of the legs touches theta, and the other one doesn't. So the leg that does not touch theta, we refer to as the opposite side. And the leg that does touch theta, we refer to as the adjacent side. Now, what if I would have chosen the other angle? So what if I put my theta over here? Does that alter anything? It just is going to switch places with the opposite and the adjacent. The h never moves. So trigonometry is just a way to link the sides of a triangle to the angles of a triangle. So we know that the triangle angle sum is 180 degrees, and we know that in a right triangle, a squared plus b squared equals c squared, but neither of those formulas tell us how big the sides are when you know how big the angles are. So to do that, we've created trigonometry. And trigonometry is based on sine, cosine, and tangent. But because we're lazy, we just abbreviate that SIN, COS, and TAN. And we always reference trigonometry to one of the angles of a right triangle. And notice, I either chose this one or this one to be theta. What happens if I choose the 90-degree angle to be theta? So what if this is theta? Anybody see a problem there? Yeah. Why is that a problem? What is this side called? Well, it's the hypotenuse, but it's also the opposite. And what would these 2 sides be called? They're both adjacent. So we can't choose the right angle as our theta. Now, that's not entirely true. The trigonometry that we're going to focus on for now, it's sort of a simplified version of true triangle trigonometry. And technically, you can choose the 90-degree angle, but the formulas that we're going to go over today won't let you do that. There is another way to do it that's more complicated, but we're not going to study that today. So, when we do right triangle trig, we have to pick a theta. Now, often in the problem, theta is chosen for you. Okay? So it'll either be chosen for you or you'll have to pick it. But the sine of theta is simply the name of a ratio where you take the opposite side and you divide it by the length of the hypotenuse. So the sine of theta is simply the O side divided by the H side. So O divided by H. The cosine of theta is A over H. And the tangent of theta is O over A. Okay? So what does trigonometry do? Well, it looks at an angle and then tells you what the ratio of the side lengths are according to this particular pattern. Now, there are three other trig ratios. So we have O over H, A over H, and O over A. We could also do H over O and H over A and A over O, and those have different names. And you don't have buttons for those in your calculator. Okay? So, if I had this, what is the sine of A? Well, how am I going to remember all those ratios? That's a lot, right? So we have a mnemonic. SOHCAHTOA. And over the years, lots of math teachers have come up with silly little statements that help you remember SOHCAHTOA. And the best one that you'll never forget is, ready for this? Some old hippie caught another hippie tripping on acid. Totally school inappropriate, but you won't forget it. Some old hippie caught another hippie tripping on acid. How does this work? Well, sine is O over H, cosine is A over H, and tangent is O over A. So in this case, theta has been chosen for me. It's A. So if we look at angle A, what would the O side divided by the H side be? So the O side divided by the H side is 4 over 5. Okay? What is the tangent of B? So if this is my theta, B is going to be the O side divided by the A side, so it would be 3/4. Okay? Hopefully this is review. I want to pull this up. There we go. So here it wants to know what is the tangent of 29. So all I have to do is type in the tangent of 29, and then I hit enter, but there are two ways to measure angles. One is degrees, and one is something you've never heard of called radians. So I need to make sure that my calculator is in degrees. So if you have a graphing calculator, just push mode, and on the third or fourth line down, it will say radians in degrees. If you're using one of the little blue calculators or your phone calculators, you should see these letters somewhere on your screen, DEG. That means that you're working in degrees. Okay. So I go back. Tangent of 29 is simply 0.554. Easy enough. Okay. Here I have a right triangle, and it wants to know what is the cosine of x. Well, cosine is adjacent over hypotenuse, so it's just f over e. Okay. Here, what is the tangent of A? So A is the opposite side divided by the adjacent side, so it would just be 7 over 24. Okay? All right. Here's where it gets a little bit tricky. I know one of the base angles in this right triangle is 32. I know that the adjacent side is the one that I'm looking for, and the hypotenuse is 7. So we need to pick the correct ratio. Remember, SOHCAHTOA. This is the A side, and this is the H side, so I need to choose the cosine. Okay? Is there another way to do this? Could you choose a different one? Well, yes. If this angle is 32, then this angle is 58, and I could choose 58 and then use the sine. So there is a little bit of flexibility. In fact, your calculator has 3 trig buttons, and with enough wisdom, you could get by with just one of them. If all you had was the tangent button, it would be a big pain, but you could figure out all of the work in terms of the tangent, which is kind of complicated, but it could be possible. Just like if you were missing the number 3 on your calculator, could you still do all the calculations? Yeah. So everywhere that you want to put a 3, you could just put parentheses 1 plus 2. Okay? Well, what if you didn't have a 3 or an 8? Would that be okay? Yeah. In fact, how many numbers do you actually need? Just one. The number 1 would be enough. It would be not any fun. 80 would be 1 plus 1 plus 1 plus 1 plus 1. And then I guess you could do 8 of those and then times it by 10. Yeah. So here, the cosine of theta, the cosine of 32 is x over 7. Okay? So here, I just need to get the x by itself. What is holding the 7 to the x? Division. What's the opposite of division? Multiplication. So I times by 7, and the answer is just 7 cosine of 32. On my calculator, I push 7 times the cosine of 32, and I get 5.9. Okay? Now, I refer to these as a multiply problem. If your variable is on top, then to get this by itself, all you do is multiply by the denominator. But sometimes the problem will be different. What if it was x and 5? We're still going to use the cosine. The cosine of 32 is 5 over x. Okay, now, the slow way to do it is this. Times by x, cancel those out, times by x, x cosine of 32 equals 5, divide by cosine 32, divide by cosine 32, and that's my answer. And that will totally work. But do you see a shortcut? From this problem here, what did we really just do? We just switched places with the x and the cosine 32. So I refer to these as switch problems, and we're just going to flip these. And we get x equals 5 over the cosine of 32. So let me remind you that first one we did. So if your variable is on top, you just multiply by the denominator and you're done. If your variable is in the denominator, you switch places with the variable and the trig function. And in right triangle trig, where you're missing a side length, those are the only two options. It's either going to be a multiply problem or a switch problem. There's no other possibility. Okay. All right. Here, they have told me that theta is equal to x, so this is a little bit different. Here we have the cosine of x is equal to 13 over 23. So in the last problem, we knew one of the angles, but we were missing a side length. And here, we know two of the side lengths, but we're missing the angle. Does anybody know how to solve these? Well, so the cosine is a function that takes angles and spits out ratios. So if you know how big the angle is, you can plug that number into your calculator and it will tell you how big the ratio is. Okay? Well, we can invert these. So in this case, I know the ratio, but I want the angle. So there's another function that will do this for us. In fact, it is called the inverse function. And originally, it was called the arc cosine. So we had sine, cosine, and tangent. And we had arc sine, arc cosine, and arc tangent. And they still sort of exist. You see them every once in a while. But as mathematicians, we became really lazy, especially when we invented calculators. And calculators have buttons that are really, really small. An arc sine does not fit on a button. It's just too long. So the arc cosine is equivalent to the cosine inverse. And you'll see those buttons above your sine, cosine, and tangent buttons. So what does the cosine inverse do? The cosine inverse takes ratios and spits out angles. So if you know the angle, you use sine, cosine, and tangent every single time. If you don't know the angle, then you use sine inverse, cosine inverse, and tangent inverse. So here, the cosine of x is 13 over 23, which means that the cosine inverse of 13 over 23 is x. So I go to my calculator and I do second cosine of 13 over 23, and it will spit out an angle 55.58 degrees. Okay? So if you know the side lengths, or sorry, if you know the angle, you use sine, cosine, and tangent. If you are looking for the angle, then you use the inverse buttons. All right. So here it wants the tangent of theta. So according to SOHCAHTOA, tangent is O over A. So we want to do the O side divided by the A side. But we have a problem. I don't know the A side. So how do I find the A side? Pythagorean theorem. So A squared plus 12 squared equals 13 squared. So I subtract 12 squared. That's 169 minus 144 is 25. Square root. And this equals 5. Now what do I do? Now I do O over A, so 12 over 5. That's my answer. What if it was 12 over root 5? 12 over root 5. I'm not allowed to leave it in this form because I have a radical in the denominator. So I have to times the bottom by itself, but that's going to change the fraction. So if I times the top by itself, what is this number really? It's just 1. Can I multiply 12 over root 5 by 1 without altering its value? Yes, we're going to change its close, but it's the same person. So 12 root 5 over 5. Can I cancel these 5s? No. Inside cannot cancel outside. Outside can cancel outside, and inside can cancel inside. But inside cannot cancel outside. Okay. Do you need to see another one of those? Okay. Well, that's not going to be, it's the same problem, right? Let's find a different one. They really like this triangle. Okay. I'm going to make up my own. I'm going to change this to a 7. Okay, what is the tangent? So the tangent is going to be x over 7. So 7 squared plus x squared equals 13 squared. Subtract 7 squared. So in my calculator, 13 squared minus 7 squared is 120. So I take the square root, and x is the square root of 120. Are there any perfect squares inside 120? 4. Are there any others? 4, 9, 16, maybe 16. I don't know. I don't know my my perfect square multiplications very well. So I'm just going to factor 2 and 60, 2 and 30, 2 and 15, 3 and 5. So 2 root, what's left? 30. So what is the tangent? 2 root 30 over 7. Okay. All right. Here we have a right triangle. We know one base angle, and we know one leg. And it says, find everything. So solve for everything. Okay. What trig ratio will use those two sides? A and H would be cosine. So the cosine of 40 is 24 over C. Is that a multiply or a switch problem? Switch. Good. So we switch those. C equals 24 over the cosine of 40. So over here, 24 divided by the cosine of 40. And I get nearest tenth, so 31.3. All right. How am I going to find A? I have 3 options. I could use the Pythagorean theorem. 24 squared plus A squared equals 31.3 squared. I could use, what trig ratio would use those two sides? That'd be the tangent, or sorry, the sine. Or I could do those two, and use the tangent ratio. One of them is a better choice than the others. Why? Well, this is an approximation. It's been rounded. So there is a chance if I use 31.3 that my answer is going to just be slightly off enough to make Alex mad. So if you're going to use 31.3, I recommend that you use several more decimal points. Or don't use the 31.3 and use the 24 instead with the tangent. So the tangent of 40 is A over 24. Is that a multiply or a switch problem? A multiply problem. So the answer is 24 tangent of 40. And lastly, it wants to know how big is angle B. Angle B is just going to be 50. So if the instructions say solve the right triangle, it just means find all the sides and all the angles. All right? Okay, that's it for today. You only need to do the first 7. Get to work.